Hi guys. So these are going to be the notes for section 1.5. This can be a little bit of a tricky section just because some of the words are going to be new to you. So just let me know if you have any questions as you're going. Maybe like write them down as you're watching the video, something like that. Really take advantage of using that form that you fill out and letting me know if you have any questions. So to begin, we're just going to talk about something called normal distribution. And basically, this is just a very important statistical data distribution pattern. Certain data, when graphed like a histogram. Now, just for the record, you might not remember what a histogram was going back to maybe the middle school. So we can search it right here. It's just basically a bar graph that's connected. So make sure I get rid of that one. So certain data when graphed like a histogram. And then I'll just keep on adding to my sentence. So creates a bell-shaped curve known as a normal curve. So the histogram example does not make that normal curve. And we're also going to call it normal distribution. So this is what the normal curve looks like. Another word for the normal curve is a bell curve. Okay. So some things that are true about our normal distribution is the fact that it's symmetrical. You'll notice here, this is dealing with grades. That's the one that's the most common. Something that's also true is that there's a single central peak. At the mean of the data. Right, so that's the average. So that's going to be the top. So in this case, the highest amount of students will be falling in between this range and that middle one being the middle, the mean. And then the graph falls off evenly on either side of the mean. And then that's where you see the symmetrical feature. And 50% of the distribution lies to the left of the mean, and 50% lies to the right of the mean. My battery is low, so I'm just going to be checking it. Okay, so that is the bell curve. So if you've ever had anybody scale something, they do this maybe more in college, but they'll make it so that 10% of the class gets an A, 15% of the class gets the B, most of the kids get a C, 15%, and then 10%. So even if your grade fell into this range, if they were doing the bell curve, they would add whatever score it takes the highest one to be in that A range. So if you were the highest, they would add however many points that you need to get there, and then they would add that amount of points. So everybody can be distributed according to the bell curve. Now, standard deviation is something that we're going to work with our bell curve. Let me go ahead and get rid of that guy. So basically, this is just something that controls the spread of a normal distribution. The smaller the standard deviation, the more concentrated the data. And I'll show you one that's talking about that. So deviation is something is changing from something else. So how far it's spread out from that particular mean. Just to let you know, we do have the symbol, and you can get it right in the insert symbol for the special characters. What it's going to look like is we'll draw it out first. It's going to look like that right here. If you highlight it, it's called the Greek letter sigma. That's the symbol that we use for standard deviation. Okay. I'll even make mine a little bit big so it stands out in my notes. So this is just saying, let's look at different standard deviations. So we just had here in the red graph, the maximum is 50. The standard deviation SD is 10 units. So that's a pretty big standard deviation. So the graph itself is pretty spread out. The bluer graph is at 50 as well for the mean. So right, that central point, the highest point is at 50, but the standard deviation is 5. So that means people are more closer related to the mean than they are in the blue. So it's not as spread out. So it's saying up here, the smaller deviation, so the smaller people are deviating, the amount it's more concentrated. That means they're more alike. So here's your first reflect question. That is not good. Hopefully you did not see that. How do the mean and the median compare to each other in a normal distribution? So you know the word median from before. So that's a question that you're going to be answering on the form. And then we have down here my normal curve. I think I'm going to bring it up a little bit. I have a lot of space here. Let's see. So this is going to be really helpful in order to see these numbers. So this is what the actual normal curve is going to look like. So just some things that I want you to notice about it. First off, about 19.1% of normally distributed data is located between the mean and 0.5 standard deviations to the right or left of the mean. So if you look at your middle, you've got 19.1, 19.1. If you look at your standard deviation, you're going up 0.5 and to the left 0.5. So this is just how many units you're moving away. That's all. Something else to notice, if you add the percentages, you will see that approximately and then we're going to point out a few things. So the first is approximately, so about 68% of the distribution lies within one standard deviation of the mean. Right, so 68%. So from 1 to -1, if you add these numbers, right, it's about 68% is going to lie within that. And then, you know what? The next couple of sentences are really similar. So I'm going to go ahead and use technology to my advantage. And I'm just going to change the percentage here. So 95% now, which is like almost everything, of the distribution lies within 2 standard deviations. So if I look from -2 to +2, I have 95% of the data. And then the third one is really almost every one. So 99.7 approximately percentage of the data lies within 2 standard deviations of the mean, or 2.5, I'm sorry. Let me just pluralize that. Approximately. Okay. And then this kind of breaks it out too. Actually, I might even add one more sentence. The fact that these percentages are known as the empirical rule. So you're going to use this table to solve some problems in a little bit too. This kind of normal curve. Okay, so this is kind of the way I'm breaking it out too. So I'm saying it, right? So from here is the 68%. Then we've got the 99% in the yellow, or 95% in the yellow, and then the 99% in the purple. A couple more things we can notice about our normal distribution is the fact that 50% of the distribution lies within 0.67448 standard deviations from the mean. Also, don't let this notation look confusing to you. So remember, X with the little line over it stands for mean. So this is like X minus 1 standard deviation, 2 standard deviations, 3 standard deviations, plus 1 standard deviation. So whatever that happens to be. If it's not, for example, 0.5, whatever it happens to be. So it's going to change. I also want you to know something called the IQR. You can see it beginning on the bottom. But this is called the interquartile range. So it's IQR. If you don't remember what quartiles are, I want you to stop right now and look that up. Box and whisker plots. You did them before in the middle school. So just make sure you catch what those quartile ranges mean if you're confused. But basically, this is just the interval about the mean containing 50% of the data. And I'm also going to add the width of an interval, which contains the middle 50% of the data set. And it's normally computed by subtracting the first quartile from the third. And that makes sense. If you look at like a box and whisker, it's broken up into the 4 areas. And I've got this nice picture showing that underneath it. So if you have your curve, right, in order to find that, I'll even write one more thing. So IQR, so that's your interquartile range. It's just your quartile 3. So control comma will give you your subset. It will make the number smaller, minus control comma 1. So quartile 3, take away quartile 1. So we're looking at this range. This is what the quartiles do. It breaks it up into 4s. So this is your median. This is your 25th percentile, 75th, and so on. So in this case, something to know about my IQR, that it's 1.34896 times your standard deviation. That's the formula. I could go in and explain this, but it would take a long time. So I'm not even going to worry about it. You're just going to remember that it's 1.3 and you're going to want to try to be as exact as possible. So use all of these numbers. And remember the symbol 1.34896 times, and then you can go ahead and put that standard deviation symbol in there. So special characters, and it's even got that for me still. So that's your formula to find the IQR. Another thing to notice is the fact that the mean is the 50th percentile, so the second quartile. Okay. There also is something called percentile rank. And this is just the area or probability to the left of the value Okay, percentile rank. And also, just for the record, that, oh, I already have that definition there. That's okay. So I can delete that now. And then the last comment I want to say about this is adding the given percentages from the chart will let you find certain percentages along the curve. And I'll show you what I mean in a second. Right, so here's an example. Right, so a student scored 1 standard deviation above the mean. Right, so notice here's the mean. Right, 34 and change percent up. So that's the mean plus 1 standard deviation. So the student performed better than 84.1%. Because remember, this is 50%. So he scored better than 84.1% of the class. It's kind of interesting when you get your SAT scores or maybe even your state testing, they're probably analyzing it using these types of information. So that would be that child. Okay, so I'm going to stop here and do another video for the examples. So this one isn't too long. Again, let me know if you have any questions.